Okay, welcome back everyone. Now that we've configured point-to-point ospf and saw the differences between using a serial connection or an Ethernet connection where the priority numbers change and there's an election or no election. So now we're understanding what can happen if we're in an Ethernet, whether it's point-to-point or not. If it's an Ethernet type network, you're going to run into that broadcast nature type of network that will actually have to create an election for DR and BDR. But for your CCNA exam, and let me move the lab the other way so you guys can see it better. This is the multi-axis lab. This is something that you will see, more than likely, a scenario like this in your examination. Now, what are we going to do here? We know how to configure ospf. We know how to advertise our networks using the wildcard mask, creating a process ID number, and all the routes in the same area. Easy enough. Easy enough. Now, understanding what's going on, it's the issue, right? Not the issue or the concern. Here we have a multi-access network, which obviously is a broadcast because we're dealing with Ethernet. We have 4 routers connected to a switch. Now you see there's only one IP address here, which is not one IP address, one network, which all the fast Ethernets will be using. So this will be, let's say, fast Ethernet 1.1, 1.2, 1.3, 1.4. And when you create this lab, go in that order at first, and then you can start playing around with it. Then we will configure ospf, advertising that one network that we're in, and then you're going to see what happens, because this is going to create an election and it's going to choose a particular IP address, and it should choose, and listen to my words carefully, it should choose the highest IP address on any physical interface to be the DR, and the second highest IP address to be the BDR. All right, once we do this and we figure out what's going on and who's the DR and the BDR, then we're going to go ahead and create loopback addresses. That's why you see the loopback addresses here. That will be the secondary portion of the lab where we create the loopback addresses. And see, and then of course advertise it in ospf and see if it chooses that loopback. Now it won't do it automatically. There's a command that you're going to learn here which is called clear IP ospf. Process, clear IP ospf process. And what that does is just that. It clears the process so it can recalculate and let the new loopback addresses take effect. Because remember, that process ID number deals with the link state database. So we need to like kickstart that because we added a new network, right? 1.1.1.1 network, 2.2.2, 3.3, and 4.4.4. Sometimes that works, and I think it's more of a packet tracer thing, that it takes effect. Sometimes it doesn't. What I like to do is go right into a switch sometimes, because I'm not going to keep trying clear IP ospf process. I'll do it on all the routers. I'll do it just on 2 routers, and it still gets a little bit whatever. When I do it on the switch, 9 out of 10 times, everything reboots. Obviously, the switch, central point of failure, everything reboots, and then it decides to take place. But again, I think that's more of a packet tracer thing. Now, real world scenario, if you're planning to do a network like this, where you have this broadcast, you do not, even though you do the clear IP ospf process, that will still take down the interfaces and then bring them back up. So you will lose connectivity. Your users will notice that. You'll lose connectivity for a period of time. All right, and then, but if you bring down the switch, that's a whole nother story right there. That's even worse. So if you are going to do something like this, try not to do it. Anything that's going to be not damaging, but affecting the network, where people are like, hey, what happened? I was just emailing something, or I was researching something on the internet and now it's gone, or I'm printing something and it just stopped, or what have you. If it's going to affect the network, don't do it definitely during peak hours. So I don't know, you wait till everybody goes to lunch, or the slow time in the network, or you do it after hours. And normally there's things called maintenance windows where you can change components, where you can, clear the, if you have no choice but to clear the process during the day, just try, send an email out first and warn everyone. Check with the higher ups before you do this. They give you the go ahead, they give you the green light, take the burden off you. All right, if they give you the green light, you go ahead and do it, but make sure that everybody's aware that they may lose connectivity for a certain period of time. You want to make sure that you warn everybody that, hey, this is going to happen. All right, if you have to do it during the day. If you can help it though, if you can do it after hours or even at midnight. And IT, unfortunately, our job is 24/7. We do things normally when it's service affecting or, that's going to affect the network. We do it between midnight and 6 in the morning. Midnight and 6 in the morning. Usually that's the time we can do a whole bunch of these things. But anyway, you just want to make sure that, hey, well, we can do this in the real world. No. Be careful before you do this testing type thing, or unless you have a separate network that you can play around with. But if you actually have a working network and you want to add these loopbacks and these loopbacks are not taking effect and you have to clear the process, know that that's going to happen. All right. Once we see what happens and we analyze, right? Because we analyze first with the IP addresses on the physical interfaces and we see who becomes the DR and the BDR. And we're going to take a look at the states and all that. And then we finally, we understand that. And then we go ahead and put our loopbacks and then we see if anything changed. And then we're going to play around with the priority numbers, I personally like to use the priority numbers because the priority numbers will trump whatever IP address physically on the interface or any loopback interface. The priority number is above all them. Now, the highest of all, the king on top of the hill, is the router ID. If you hard code, which is something Cisco recommends, if you hard code the router ID, meaning you actually type in within the ospf router configuration mode and you put in the router ID of that particular router. Remember, the router ID is an IP address, an IP version 4 format IP address, which is the name of the router. That is how that router is identified. So the one with the highest router ID will always be the designated router, and then the second highest. So, and that will trump everything. Cisco recommends to do that. Well, we'll stop at the priority number because again, sometimes this lab can get a little flaky and it could be due to the packet tracer, but we'll take it a step at a time. And we see here, the whole purpose though of this is to understand the election process, Now, there is no IP addresses configured. We're going to have to do it ourselves. I'm sure by this point, we all know how to put IP addresses in the interface and turn them on. And that's all we're going to do. We're not going to do any admin configs or anything like that. We're going to go ahead and put IP addresses. But the way that I want you to do this lab, and for whatever reason, every time I say this, somebody goes off on a tangent and does it their way and say, well, mine doesn't look that way. Well, did you do this? No, then. Okay, then. So if you're going to do this, at least the first time around, okay, do it how I'm going to do it. I'm going to configure it in this order. This is why they have router 1, router 2, router 3, and router 4. I want you to do it in that order. I want you to put the IP addresses in that order. And when we configure OSPF, I want you to do it in that order as well. 1, 2, 3, 4. There is a purpose. There's a method to the madness of why I want you to do it that way. And you'll see it pretty soon. So let's go ahead and configure the 192.168.1.0, which is going to be all your LANs. All right. And let's start by router number 1. And we're going to go nice and easy. No hurry here. We need to understand the election process of the designator router and the backup designator router. All right. How that happens. Enable config T. Let's name this router 1, host name R1. So I didn't lie, I didn't say everything. All right, we give it a name, host name router 1, interface F0/0, IP address 192.168.1.1. Right, we're in the 1. I want to make sure that we are in the 1. All right, and let's open it up further. And then we put in the mask 255.255.255, .0. And we do a no shut. And I'm going to do a do WR. All right. So we're done with router 1 for now. We just put the IP address on that particular interface. We're going to do the same thing here, but this one will be 1.2, 1.3, and 1.4. So let's go ahead and do that. And you know what? Let's just maximize it because it's going to be right there anyway. Not to waste time. Enable, config T, host name R2, interface F0/0, IP address 192.168.1.2, 255.255.255.0, no shut, do WR. Done deal. Very simple. All we're doing is putting an IP address on the fast Ethernet 00. Nothing major. All right. Config T. We'll put in the host name R3, and then interface F0/0, IP address 192.168.1.3, 255.255.255.0. The purpose is, again, understanding what is it that we're doing rather than just do a whole bunch of configurations that things don't make sense. Now what I did there, I did a fat finger the keyboard, so I tried to resolve using DNS, but since we don't have DNS configured, I did a Control-Shift-6, and it went ahead and broke it, and then I did the correct command, which is do WR. And that was router 3, so let's go to router 4, which is our last router. Let's say no, enable, config T, host name R4, interface F0/0, IP address 192.168.1.4, 255.255.255.0. Enter, and then no shut. All right, do WR. So we've put the IP addresses on these interfaces. Just as a side note, you can see, because later on we'll be, after the routing, we'll be doing the switching. Pay attention that these amber lights, remember that's STP that's working on there, and that's the reason those amber lights are there. That's why it takes time before it turns green, turns a port into designated forwarding. Give me a heads up on the switching. All right, so we'll wait till that turns green. La la la, there you go. All right, so now we've put in the IP addresses. Obviously, we could probably ping each other. There's no need for a routing protocol, but we are going to use a routing protocol. So now we're going to go in the same exact order, and we're going to advertise that network. We're going to advertise a 1.0 network. All right, we're not going to do the loopbacks yet. We're actually going to do just the 192.168 1.0 network. So let's bring back router 1. All right, and let's maximize it like we did with the rest. And I can just exit from where I'm at. I'm going to do router ospf 1 network 192.168.1.0. It's a 24 mask, therefore 255 wildcard mask, and we're going to use area 0, right? So nobody freaks out that I'm using a completely different area. All right. In practice, you can use whatever area you choose. In a real world scenario, meaning when you go out there and work, your first area must be 0. Remember, your area 0 is your backbone. So just putting area 0 there just to stay along the lines of the certification. But when you're doing practice, you can put whatever area you please as long as they're all the same as far as for single area OSPF. All right, so we're going to go router OSPF 1 network 192.168.1.0 0000255 area 0. Do WR, and then that one gets done. Let's go to the next one, which is router 3. Let's maximize that. We're going to exit once. Router OSPF 1 network 192.168.1.0 0000255 area 0. Do WR. And then, oops, no, there you go, full loading done. Did I advertise the correct network here? Yeah, I did. 1.0, okay. I was wondering why it took a while for it to say full loading done. Well, it is a hefty protocol. All right, exit, router, ospf 1, network, 192.168.1.0, 000.255, area 0. Do WR. We do a control Z. Obviously, if we look at the routing table, we're not going to see any O's or anything like that because we're directly connected. We can see, we still say it says full loading done. So ospf is doing its thing. So what we want to look at, now I said that the highest IP address is 1.4, is the fourth router. And the second highest is router number 3, which is 1.3. So let's take a look at show IP ospf interface F0/0. And as we've seen in the previous labs, when it's Ethernet, here we see the network type broadcast. We have a priority of 1. All right, but look how funny. We're using the lowest IP address as the designated router and the second lowest as the backup designated router. And why is that? The reason that is because when you, in the order that we did it in, when that first router came up, it said, hey, I'm the only ospf process that's running in this infrastructure, so I'm the man. And then the other router comes up and says, well, I'm not the only one, he's the one, so he's going to be the designated router, I'll be the backup designated router. And then the others are just what they call druthers. And how do we look at that? Well, if you look at show IP, ospf, there's several things you can look at. Border routers, database, interface, or neighbors, right? You take a look at your neighbors. And these are your states that we talked about when you become when you're trying to become neighbors with each other. 1.2 is the backup designated router. 1.1 is a designated router. And he has done a full relationship with all the routers. Full relationship with all routers. But look at 1.3. It stopped. It stopped at the two-way. And that's what I mean. You need to understand what that means. That state is it stops exchanging information with that particular router because they say, hey, we have DRs and BDRs, so I'm going to make a full relationship with them, but not with you. Because all the updates from the designated router other or druthers, again, where they came up with that name, I don't know, they're going to name something else, but whatever. It is what it is. The other routers that are not BDR or DR, they're just standard old routers. They say, hey, I'm not going to make a full relationship with a DR or BD, with any standard any old router. I want to make a full relationship with the BDR and the DR, because those routers is where I'm sending my updates to. So it stopped the neighbor process at two-way. And we were to look, and this is from router 4. We will go to router 3, we will see the same thing. We will see the same thing. We'll go to router 3, Control C, no, maybe so. Okay, show IP, ospf, interface F0/0. Again, we see that the designated router is 1.1 and then backup is 1.2. Broadcast priority of 1. Therefore, there is an election. And don't forget, these bad boys right here, if they're different on your neighbor routers, you will not create relationships either. That's the criteria, remember? Same autonomous system, same subnet mask. Security, if configured, and or authentication, and the hellos and deads must be the same. In order for that neighbor relationship to be created. All right, so we're going to do a show IP ospf neighbor, and you see that with 1.4, we did not create a full relationship. We created a two-way relationship. We stopped at that point. We stopped in the relationship process. We did not continue. But we did create one with the BDR and the DR. Let's go to the DR and take a look at that. So it's important to understand that. Show IP OSPF. Let's just look at the neighbor. Go straight to there. You can see that the DR has full relationships with everybody. It has a full relationship with the BDR and with the other routers. Because everybody's updating him. Let's take a look at the BDR now, which is this guy up here. See what he has. Show IP OSPF neighbor. Same thing. Because they're the ones that need to have that full relationship because everybody's updating them. And then the DRs are updating everybody else. All right? The BDR is there in case the DR goes down, he takes over. But again, the other routers do not need. So you have 50 routers. Remember you gave that number, that magical number, 50 per area. You don't want all those drothers, right, or designated router others updating to each other. So however or how many DRs, well, no, it's going to be one DR and one BDR per segment, per broadcast domain. One BDR and one DR. So let's say you have only one, or you have two. So you have one DR over here, one BDR. What would be an example of two? Imagine that we're in the same area, but in between here there's a serial, okay, point-to-point serial connection, and then over here we have another star. We have another one of these over here. But in between we have a serial connection. Therefore, you have one multi-access network here, one multi-access network there. You will have one DR and one BDR per multi-access network. Sounds like a question to me. Sounds like a question. All right, so be aware of that. So we see that it's not doing what it's supposed to do. What it's supposed to do is say, hey, this should be the DR and this should be the BDR. So let's do that clear IP OSPF process, right? So I'm going to come to router number 1 and I'm going to clear IP OSPF process. Hit enter. I'm going to say yes. Why yes? Okay, I got to type in yes, and it's got to be exactly there. Boom. Done, right? And I'm going to do it to this guy right here, and let's see if it clear IP OSPF process. Yes. All right. So let's see if that's good enough. Let's wait for it to do everything it needs to do. All right. When all the full loading has stopped. Okay, we see the 4, the 1, the 3. Okay, and 2 is itself. Okay. So let's take a look from router 1, that was the original DR. Control Z here, if it lets me. Okay. And I'm going to type in that show IP OSPF. No, I'm going to type it here. Show IP OSPF interface F0/0. Show IP OSPF interface F0/0. All right, now what do we see? Now we see that our designated router is 1.4 and our backup designated router is 1.3. Packet Tracer wants to work with us today. Outstanding. So now it chose the right ones. Now let's see, because this had full all the way down, right? The state was full. Let's take a look at that show IP OSPF neighbor command. And now what do we see? Now 1.3 and 1.4, we have a full relationship with those routers because those are the designator and backup designated routers. Where router 2, we have a two-way. So see how the election process works sometimes? Because if it's, and you can say, well, Lance, my God, if I'm creating a network and I'm going across the entire globe, and well, this is the process that it takes. That's why Cisco says sometimes it's better to hard code the router ID within the within the OSPF process. Let me show you what that means. Router, and we did router OSPF 1, so we're in router OSPF 1. And if you type a question mark, there's a command right down there. Router ID. So if you put the router ID yourself in an IP version 4 format, then that's it. You won't have to worry about that. You have to worry about that particular election because you're fixing the election. Or you use priority numbers. But I want you to understand that this is what really happens if you let it up to OSPF to, hey, let's run an election, let's see what happens. So as routers come up with their routing protocols, because you can't be like, all right, guys, everybody together on a conference call across the world. All right, we're going to start typing now, okay? And then we gotta be in sequence so we can all try and come up together so we can get the right. It's not going to happen. So everybody has a particular router ID. Everybody will have maybe a priority number. And that's why you have multiple areas. Everybody's in charge of that particular area, real world, okay? But you are taking a certification. Single area, you're not going to go beyond 3 routers. All you need to be concerned with, hey, the highest IP address, right? The highest IP address on any physical interface will be the DR, and the second highest will be the BDR. Unless, and what we're about to do, I create loopback addresses. Then if I create loopback addresses, it will use the highest loopback address as the DR and the second highest as the BDR. And the reason why, they're virtual. They never go down. And that's one of the reasons that they like to use it. So let's go ahead and configure that now. So we're in router 1, which is great. Let's exit. Let's go. And this is LO1, if I'm not mistaken. Let's make sure that we have the naming convention down right. LO1, LO2, LO3, LO4. Pretty simple to follow. All right, and we're using a 32-bit mask. All right. So we're going to go interface LO1. All right. You don't need to do a no shut. It turns on by itself. IP address 1.1.1. Okay, no block. 1.1.1.1. 255.255.255.255. Enter. But we need to advertise that within OSPF. So we go router, OSPF 1, which is the process. And then we go network, 1.1.1.1, 0.0.0.0, area 0. Remember, your wildcard masking, constant number on top, all 255s. Well, then we got 255s as the mask. Therefore, they're all zeros. Remember your wildcard masking math. Very simple. Okay, let's go to router 2. Do the same thing, but with a different loopback address. Okay. Config T. Interface LO2. IP address 2.2.2.2. 255.255. Oops. 55.255.255. Enter. We're going to exit once. Router OSPF 1. Doesn't matter. Process ID number. Network 2.2.2.2. 0.0.0.0. Area 0. Enter. Do WR. We go to router 3. Same exact thing. It's becoming kind of like whatever, right? Config T. Interface. LO3. IP address 3.3.3.3. 255.255.255.255. Enter. Exit once. Router OSPF 1. Network 3.3.3.3, 0.000, area 0. Do WR. And remember, do WR, we do it here, but when you go take your short vacation, you have to exit back to privilege mode and do a copy, run, start, enter, enter. Now remember that when you go take your examination, okay? So you don't come back and say, last, but you did a do WR and we tried it didn't work. I think I said this a million times throughout the thing, all right, throughout the course. All right, so let's do the last router, int LO4, IP address, oop, one too many S's, 4.4.4, 255.255.255.255, exit once, router ospf1, network 4.4.4.4, 0.0.0.0, area 0, do WR, Control Z. And I haven't seen any full loading done, have you? Show IP route. We do have, let me see, I'm getting O's from the 1, I'm getting O's from the 2, I'm getting O's from the 3. Okay, so we should be able to ping, let's test for connectivity, right? So we should be able to ping 3.3.3.3, awesome. 1.1.1.1, awesome. And then 2.2.2.2. So we are getting across to all the loopbacks. Let's see who the designated router is now. Show IP ospf interface F0/0. It is still using the IP address on the physical interface. That is not what we want. We want it to be the loopback address. So let's do the same process we did before. This is my DR. So I'm going to go clear IP ospf process. Let's tab that, enter. Yes. Okay. And then we go to the BDR and let's clear that process there. Hopefully it'll work like it did before, nice and easy. We don't have to get all crazy. All right, clear IP ospf process. Yes. All right. And we right see it says detached, detached, detached. Now we're loading done with 4. Loading done with 1. We got to see all the, we got to wait till everything starts populating. All right. Should be. I'm just, no patience. I'm the guy that's always pressing the button on the elevator. I want to go down, I want to go down, I want to go down. So let's do show IP route. Let's take a look at the routing table. See, it takes time. I only see the 2. I'm only getting updates from the 2 now. All right, so it's going to take a little bit for it to learn everybody. Just the way it is. Let's see what we see here. Yeah, same thing. It's taking its sweet time. That is ospf. Show IP route. Yeah, we don't even see anything. All right, so what I'm going to do is I'm going to go in here because I really don't want to wait. And definitely this is something, you know, that you don't want to do is reload. All right, because once you reload a switch, it brings anything that's connected to it, it brings it down. So now we gotta wait till everything just went down. Your whole network went down, and now it's coming back up. So we just need to wait because now spanning tree's got to do its thing, and it's gonna look to see if this is a designated forwarding port and all sorts of craziness. All right, and then until that comes up, then the routers can send their information through ospf, so ospf can do its calculations. Well, so they can become neighbors, so then they can do their calculations, and then all the updates get sent. So clearing the clear IP ospf process definitely would be the best way to go. But if it's acting up, especially with the packet tracer, that's what I do. And if this doesn't kickstart it, then understand the concept and we move on. and we move on. So let me pick this router 1 over here. I think we got it now. You just got to be a little bit forceful. Slap it around a little bit. Show IP route. Oh, you see? Nice slapping me around. All right, show IP route. Spoke too soon. All right, successful loading done. What are you doing? Show IP route. There it is. There's the 4. Come on now. So while we have this time to wait, before OSPF decides to get all its networks back up and running, let's talk about the CCNA certification, if you will. Now, I've been asked a question that there's apparently a new CCNA. I haven't heard yet of a newer CCNA version. The 200-120 is the one that I know of. Up to this point, the things that we've covered is the things you need to pay attention to for your certification, especially here with OSPF. Same area. Hellos have to be the same. And with the election here, the multi-access. Okay, now this thing doesn't want to play. What's going on? Come on. Loop back. I advertised it. Okay. Is it really taking that long? I should be able to see all the show IP route. There we go. Here's the 2 network. There's the the 1 network. I'm sorry, the 1 network, the 3 network, and the 4 network. So router number 2 is seeing all the networks. Let's see router number 3. Show IP route. He's good to go. I see the 1, I see the 2, and I see the 4. Okay. Let's see the 4 network. Router 4, I'm sorry. Okay. Something's going on between router 4 and router 1 that they just are being who they want to be. And let's go to router 2 that sees everyone. And let's do a show. Ooh, look at all those routers are open. Let's close that. Okay. And router 2. Let's do a show IP OSPF interface F0/0. And let's see if at least there's and it's still not using, it's still using designated router 1.2 and 1.1 as a designated router and backup designated router. So it's going a little crazy. All right, so we're not going to really waste time. What should happen is that this one still should have been your designated router and this one should have been your backup, because these are the 2 highest loopbacks. And if you get questions asked on your exam, or you get a print screen or what have you, and their loopback addresses, the highest loopback addresses will be chosen over the physical interfaces, right? The IP addresses on the physical interfaces. And it will be the highest loopback addresses that would be the DRs. All right? That's what you need to understand. Because this is just being silly right now, and I really don't have time for the packet tracer to say, hey. So what we're going to do, all right, we're going to go to the next step, which is the priority numbers. The priority numbers. The one with the highest priority number, and the range is from 0 to 255. 0, you saw it. If your priority number is 0, you do not take part in any election. You're excluded from the election process. All right? If you are any other number than that, by default, all these guys' priority numbers right now are 1. So that's why it cannot be the tiebreaker. The tiebreaker will be the loopback addresses. So what we're going to do is we're going to configure router 2 as a designated. As a matter of fact, let's take router 3. Let's make router 3 the designated router, and let's make router 2 the backup designated router by giving them a higher priority than the ones 1 and 4. All right? And this is, now I'm going to obviously always go to the extreme. So router 3, I don't want nobody to trump him, so his priority will be 255. And the priority for 2 will be 254, second highest. So let's go ahead and do that. Very simple. We go into the interface, config, T, interface F0/0, IP ospf priority, right? And you can see the range, 0 to 255. All right, let me bring that up so you can see it better. You can see the range is from 0 to 255 for the priority number, and we're going to choose, I did an up arrow, we're going to go ahead and do 255. That's for router 3. There's no advertising or anything like that with an ospf. You're changing a priority number on the interface. You're already advertising the networks that are on the interface, so all this information gets sent out in the updates. So that's router 3. Router 2 will have 254 on the fast Ethernet 00. So config T, IP ospf, process, and then we'll make it 254. Oh, whoops. I thought I was already on the interface. F00, IP ospf, process, going too fast for my own good. Priority is 254. Wow, Laz. It's not good aging. Do WR. Now, for this to take effect, it's not going to take effect right away. So what I'm going to do is, I'm going to restart my switch. Lab environment. You got to love it. You can clear the process if you like in a real world, okay? Or if you are going to reboot the switch, if you get the go-ahead from the big wigs, they can do it during the day. You take that, send out an email to your higher-ups. Hey, man, I need to do this. Do you want me to do it? Yay or nay? Yay, cool. You have it in email, black and white. You cover your butt. All right? We used to say your fourth point of contact. All right? Never just do things acting on your own. Don't do that, especially something like this. Reload. All right, because usually things are done during the maintenance window. I can tell you from experience with the telecom industry. You do not, emails will save your life. You do not want to take down the network during the day. You don't want to do that. If you get permission from the higher ups, because once you tell your boss will tell his boss, and that boss will tell the people on top, and how important is this? Do we really need to do it? Once they finally said, okay, go ahead, but we'll do it between this time and this time, send out an email, warn everybody, hey, this is what's going to happen from this time to this time. You're not going to have any internet. You're not going to have this or email, whatever, for a period of, let's say, 20 minutes, 30 minutes. So just bear with it. Now save all your work or all this other stuff. So you want to make sure that if you're going to do something like this in a real world, that you let everybody know before you do it. But more than likely, if it's not that crucial at that moment because the network is working and you're just doing it for, you want this router to be the DR, and usually it picks itself, but if you want to manipulate it that way, then you normally do it during the maintenance window or a time where there's nobody there, after hours, okay? So let's see if my boy over here, show IP ospf neighbor, and look at that, 1.2 254 is my BDR, and then I got full relationships going all the way across. So that means that if, where am I? I'm in router 3, router 2 is my BDR. That makes me the DR. So we're going to do show IP ospf interface F0/0. And what do I have, pray tell? 3.3.3 is my designated router, and my backup designated router is 1.2. I can care less about what IP address they're using. Just the fact that router 2 is my BDR and router 3 is the DR, I'm happy with it. Because remember, I am basing it on priority numbers. This, these IP addresses, whatever, doesn't matter. What matters to me is who is the DR. Again, and I based it off priority numbers. So it's working. Let's go to the DR and, the BDR, and take a look at that to verify. Come on now. Show IP ospf interface F0/0. And here, you saw designated router is 333. Backup designated router is 1.2, which is myself. So it is working. It is working. The priority numbers works just fine. My personal opinion, that's what I would do. I would choose priority numbers. But if you're, in a large enough network where it goes over 255, and again, you can only have one designated router and one backup designated router within each multi-access network. So that really doesn't even come into play. But a lot of people do like hard coding the router ID. That's another option. That will be the highest option, right? Which Cisco recommends. But again, this is what a multi-access network is all about, and this is how you're going to get tested. Get very friendly with that particular screen. And I think I told you this at the beginning when we did the point-to-point. Right? Let's hit return. Show IP ospf interface F0/0. Get familiar with this screen. Understand the priority number. Understand what draw there means. It's a designated router other. It's not a backup designated router. It's not a designated router. Okay? See who your designated router is and who your backup designated router is. Okay? And the type of broadcast you're in, and obviously your hellos and deads. This screen, I'm telling you again, get familiarized with it, understand what it's doing, and always remember this, that comparison that we did. You will run an election in Ethernet. You will not run an election when there's serial cables involved. All right? Testing purposes, point to point, no election. Multi-access, election. Okay? I hope this helped. I'll see you in the next session.